Welcome to the next video on finding functions for your college algebra training. In the last video, I showed you how to use a system of equations to find a functions equation. In this video, we will use matrix equations and an Excel spreadsheet. College algebra students learn to use both methods, so this video will help you prepare to teach them. First, we're going to go over some matrix basics. Maybe you've used them before, maybe you haven't. By the end of this video, you'll be a pro at this. So first, we're going to look at the system of equations that has the variables a, b, and c. You'll notice I color-coded their coefficients. That's going to help us make a matrix equation. We're going to take all of the coefficients of a, b, and c and put them in one matrix, a 3x3 matrix. And then all of the variables are in the matrix next to them. They're being multiplied. Matrix multiplication works in this way, where you multiply 2 times a, 3 times b, and -1 times c, and those all get added together. So this really interprets the first equation on the left in our system of equations. And then the next row is 1, 4, and 3 to give you 12 over here. -1, 0, and 1 to give you 8. Notice the 0 comes from not having a b term there. And then, so our answers go over on the right-hand side, 3, 12, and 8. This is a matrix equation. Just like any equation, we can solve it using inverses. So, for example, if I had 3x minus 5 equals 12, I could use inverse of adding 5, and then I would divide by 3 to solve that equation. So we can use an inverse in a matrix. We can use an inverse in a matrix equation as well. So we're going to find the inverse of the matrix and then multiply on both sides of this matrix equation, just like you would in solving a linear equation, right? We'd add 5 to both sides. Now there are ways to find the inverse yourself, but today we're going to have inverses made for us in Excel. So here's one already made of that. We call this on the left the coefficient matrix. Okay, so here's the inverse of that coefficient matrix, and we're going to take it and we're going to multiply on both sides of the equation that inverse. Now this is very important because matrix multiplication is not commutative. It's not the same both ways, like 5 times 3 is the same as 3 times 5. Matrices don't work that way. So it's very important when you multiply that the inverse goes first on both these, and we'll look at that again in Excel in a minute. So multiply both these. On the left, you notice we have lots of 1s and 0s. This is called the identity matrix, and if you've done everything right, you will get this at the end of your process. You should have an identity matrix on the left, because what that tells us is 1 times a plus 0b plus 0c gives you -10, so that means a equals -10, and so forth. Well, look, there it is. A equals -10, b equals 7, and c equals -2. So in this way, we didn't need to use elimination or substitution. We just needed that matrix inverse and multiplied it, and there you go. So this is what our process is going to look like when we get to an Excel. So first, we're going to decide from the data points that we have which function we're looking at. You can graph it in Excel. We can check the differences. You know from earlier videos that first difference means linear if they're constant, and second difference is constant means quadratic. Third difference is means cubic. We haven't talked about that yet. It means a degree of 3 if those differences are constant. From that, we'll decide what kind of equation we need, make an equation, put it into a matrix equation like we saw on the last slide. Then we'll find that inverse using Excel and multiply by it. Inverse first, like we said, that's very important. And then we will have the values that we need to make our equation. Let's go ahead and head to Excel and see how this works. Let me switch over. Here we are in Excel. Okay, so the process is still here for you to refer back to it. First, we're going to decide which of these functions is here. So I have that selected. I'm going to go ahead and insert a graph, a chart, scatter plot. Oh, well, that is definitely looking like a parabola, looking quadratic, but we can, of course, check our differences. Let's do first difference. And we're going to, the first one we can't do because there's only one data point, and so we're going to start with the second one. and subtract those. We got a negative 47. Not constant, so we know for sure it's not linear, which we could also tell by that graph. Definitely not a line. Let's look at the second difference. Again, I can't start where there's only one data point, so I'm going to go down 2 and subtract the first differences. And I got 6. Ta-da! That is definitely quadratic because the second differences are constant. They are always 6. So we know we're going to have a quadratic. I'm just going to make myself some more room here. Alright, we'll leave that graph over here. And I'm going to start building up my equation. So, standard form quadratic equation is y equals ax squared plus bx plus c. However, I'm going to write it backwards so that I can have my y's on the right side like we did in that other matrix equation. So, I'm going to have ax squared, and I'm going to give myself some room. Let's go ahead and put a plus sign there. And then bx plus c. So, every time there's a new coefficient, oops, not doing that. Every time there's a new coefficient, I'm just giving myself a new column. Alright, I'm just going to have an equal sign. And then over here, we're going to put y. Leave some space open. I'll show you y in a minute. Alright, so we're going to have ax squared plus bx plus c. And we're going to need 3 points, just like we did in the other video. We need 3 points to make a quadratic function. So I'm just going to pick these 3. Let's go ahead and make them pretty. There you go, nice and yellow. So I'm going to pick these, and every time I see an x, I'm going to plug in the x value. So ax squared, I don't know what a is, but I'm just going to write its coefficients here. So I'm going to take that first point, I'm just going to use Excel to reference it, and I'm going to say square that. Of course, it's going to be 0 squared. I'm going to do that with every single one of those points, 1 and 2. So 1 squared is 1, 2 squared is 4. There you go. B times x. We don't know the value of b, that's what we're trying to find. So I'm just going to put the value of x here, 0. And then we should have 1 and 2. By the way, if we had chosen to use all of the points, that is called a regression. We're going to get to that in a video later on. Notice there's no x with the c, it's just c by itself. So in front of it is just a 1, that's its coefficient. All of these are going to be 1s down the row. And we're going to multiply that by a, b, c, right, to get the matrix equation. I'm going to go ahead and put borders in so that it looks more like a matrix. I'll do that over here, times this matrix. Well, I should have put my equal sign here because it's an equation. So I'll put it right here, equals. Alright, and now my y values are going to go here. So those are going to be starting off with 5. Oh, that process is in the way, isn't it? Sorry, man. And then 6. Oop, go ahead and just drag that down. 5, maybe. Get the box is in the way. Oh well. And then 13. I could have picked any 3 points. These are just the ones that I wanted to pick. Alright, so we have our matrix equation. Let's go ahead and give this a border so it looks like a matrix so we can see. Alright, so now we have our matrix equation. A 3 by 3 matrix multiplied by ABC, our variable matrix. And then it equals 5, 6, and 13. So those are our matrix equations. That's step 2. Next, find the inverse of the coefficient matrix, which is over here with the 0, 0, 1. So we're going to use Excel's fancy function. I call it minverse, but it stands for matrix inverse. Click on that. Oops. And, oh, I don't need help. Sorry, go away. And then our array is that whole matrix, so our 3 by 3. And there you go. This is the inverse of that coefficient. Check, we've done step 3. Step 4, multiply the inverse on both sides of the matrix equation. Inverse first, so I always want to put that in. Okay, so that function was minverse that we used in Excel. This next one is going to be multiplying, so let's label that. That's our next step. So equals MMULT. I call it MMULT. So we multiply whichever array you put in first is the one that gets multiplied first. So that's why we have to do inverse first. Okay, comma, and then our second array on the left-hand side is going to be our coefficient matrix. And this is where we should get the identity. Fingers crossed. There it is. And what you multiply to one side, you got to multiply to the other. So we're going to do it again over here with the y values. All right, we still got our ABC. Put that right there. Oh, multiply. There we go. And equals. All right, and we're going to multiply here. So we're going to type in again, mult. And our first array, inverse first. So we have to do the inverse first. And then our y values over here. Now we got the identity over here. That means this is going to be all of our answers. So that means that A equals 3, B equals -2, and C equals 5. So our final step is to create the equation y equals ax squared. So that is 3x squared plus bx, or -2x. Let's go ahead and do -2x. Plus c, which we kind of could tell already because of the 0 and the 5. That was going to be our y-intercept, right? Plus 5 is our c. We have found the equation. Really, only 2 steps, inverse, and then multiply once you get everything set up. It's not too bad. Now you know 2 different ways to find these equations, both of which students who take Math 110 or College Algebra need to know. So you can help them out with this. Well done.